Okay, so this is section 9.2, special right triangles. And in this section, we are going to learn some shortcut rules for solving for the parts of right triangles if they satisfy certain criteria. And the first of these triangles is the 45-45-90 triangle. So we see that it is an isosceles right triangle, and it can be formed by cutting half of a square. So we know that a square has four right angles. If we cut it in half by the diagonal, then that gives us a triangle that has a right angle, and the other two angles are right angles cut in half, so they're 45 degrees each. So if these two angles are congruent, they are the base angles, and that means that we have congruent sides by the base angles theorem. So it is a right triangle that is also an isosceles right triangle. And instead of putting those congruent marks in, you can just simply write in the angle measure of 45 degrees. And this is a 45, 45, 90 triangle. Now, the special rule that accompanies this is that the hypotenuse of a 45, 45, 90 right triangle is square root of 2 times the length of the leg. And that is what's described here in the theorem. You can prove this with the Pythagorean theorem. So if we were to just take a right triangle that was 45, 45, 90, and say the sides of the square were x, then the hypotenuse would be c, and we can say x squared plus x squared equals c squared. Add these together and you have 2x squared equals c squared. And if you take the square root of both sides of this equation, that gives you the square root of 2 times x is equal to c. So the square root cancels with the squares. And we see that if x is the length of the side of the triangle, then square root of 2 times x is equal to the hypotenuse. And that's what we have here. So we can apply this to triangles that we identify as 45, 45, 90. So we look at this, we see there's a right angle there. They tell us one of the angles is 45. Since all angles must add up to 180 degrees in a triangle, that means this angle also is 45. And we say the 45, 45, 90 rule applies. Since the leg is equal to 8, then the hypotenuse is equal to 8 root 2. And again, you can solve this by using the Pythagorean theorem, but the 45, 45, 90 rule gives us a quick way to get the answer. If we look at example B, because they're showing us that these two sides are congruent, they're both equal to x, that means that it's an isosceles triangle and the base angles must be congruent. Since we have a right angle with two congruent base angles, again, this must be a 45, 45, 90 triangle. Therefore, we can apply the 45, 45, 90 rule, and it says that the leg times square root of 2 is equal to the hypotenuse. Well, we have x times square root of 2 is equal to the hypotenuse, which is 5 square root of 2. If we divide both sides of this equation by square root of 2, we see that the root 2's cancel, and we can say that x is equal to 5. So we're able to use this in both directions. Either if we know the leg, we can find the hypotenuse, or if we know the hypotenuse, we can divide by root 2 to find the leg. The other special right triangle in this chapter is 30, 60, 90. And a 30, 60, 90 triangle can be formed by cutting an equilateral triangle in half. We understand that equilateral triangles have all of the angles equal to 60 degrees. So if we cut it in half with the altitude, we have a 60-degree angle. The altitude must form a right angle that's 90, and then the amount left is 30 to complete the triangle. So in a 30, 60, 90 triangle, we will have a different set of rules that can be applied. Let's look at the theorem. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is √3 times as long as the short leg. So if we look at this, if the hypotenuse is 2x, and it is twice as long as the short leg, that means the short leg is x, and the longer leg is √3 times the short leg. We can apply this to this example here. 10 is the hypotenuse, so 10 divided by 2 would tell us that 5 is the short leg, and 5 times √3 would give us y, so y would be equal to 5 √3. That is using the shortcut for the Pythagorean theorem. If we wanted to prove this by other means, we can say, well, an equilateral triangle that has all three sides equal to 10, when we cut it in half, we would get a triangle that has a hypotenuse of 10. When we cut it in half, the base would become 5. And then through the Pythagorean theorem, you can solve for the third side. You would get x squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. Subtract 25 from both sides, and you get x squared equals 75. And if we take the square root of both sides, we get x is the square root of 75. 75 is 3 times 25, so we can say x is equal to the square root of 25 times the square root of 3. X is equal to 5 √3. We did not have to do all of this work. We can simply say it's a 30, 60, 90 triangle. We just have to take the short leg of 5, multiply it by √3 to get x. All of this extra work was done to show you that these special right triangle rules are based on the Pythagorean theorem, and once we recognize that we have either a 45, 45, 90 or a 30, 60, 90 triangle, these rules are just saying we have a shortcut. We know the pattern for solving Pythagorean theorem with these types of triangles. So here we have another example, and we have to recall the rule. We say it's a 30, 60, 90, and we understand that the hypotenuse is the longest side of the triangle, but the hypotenuse is twice as long as the short leg. We know that the short leg is opposite the smallest angle, so x is the short leg. So you see we're using the inequalities in a triangle. The smallest angle is opposite the smallest side. So we have the hypotenuse is y, and we have the short leg is x. So that if we plug it in, we get y is equal to 2x. That's two variables. I can't solve it, so let's set up the other equation. And the other equation with 30, 60, 90 says that the long leg is equal to the square root of 3 times the short leg. So we see that 9 is the long leg. It's opposite the 60-degree angle. We'll plug in 9 for the long leg. √3 times the short leg. We said the short leg is x. Now we have an equation with one variable. We can solve this. So we will divide both sides by √3. Anytime we have a radical in the denominator, we rationalize by multiplying by √3 over √3. Any number over itself is the number 1, but when we multiply a root by itself, it will cancel the radical. So we get 9 √3 over √3 times √3 is the square root of 9 equals x. The square root of 9 is 3, so we will continue with this and say 9 root 3 over 3 equals x. And then we see that 3 will cancel into the 9. We can say that x is equal to 3 square root of 3. That is our short leg. And the hypotenuse is twice as long as that. So since y is the hypotenuse, it will be 2 times 3 root 3. This gives us y is equal to 6 root 3. So sometimes we have to work backwards with our formulas. Again, the first thing we want to do is identify, is it a special right triangle? If so, which kind? Once we know which kind, we have to write down the rules. So this is rule number 1 for a 30, 60, 90, and rule number 2. And then we substitute into those rules. Here we saw there were 2 variables I couldn't solve, so I go to the other rule, and when we plugged in, we only had 1 variable, so we worked it out and solved. We found that x was 3 root 3. Then we can take that x, which is 3 root 3, and plug it into the other equation, and we got y was 6 root 3. So here we want to be able to learn to use these rules so we can get the answers in a rapid way. Because we see that number 1, both legs are x, that means that it's isosceles. These 2 angles are congruent. This must be a 45, 45, 90, which says that the hypotenuse is square root of 2 times the leg. So they gave us the hypotenuse, which is 2 root 2, and is equal to square root of 2 times the leg. After the root 2's are canceled, we see that 2 is equal to x. If we go to number 2, again, we see it's isosceles. Both legs are root 2. We can put in our congruent marks. This must be a 45, 45, 90. Y is equal to the square root of 2 times the short leg, which is the square root of 2. Y is equal to the square root of 4. Y is equal to 2. So you see, we want to be able to develop this rapid math ability with our special right triangles. Number 3 is a 30, 60, 90. We see that 30 is opposite the root 3. That's the short leg. And x is opposite 60. That's the long leg. So x equals the long leg. And the long leg is equal to root 3 times the short leg. So since the long leg is x and the short leg is root 3, x is equal to the square root of 9, or we can say x is equal to 3. And in number 4, we see that 2 plus 2 is 4. This is an equilateral triangle. So when we cut an equilateral triangle in half, that gives us a 30, 60, 90 triangle. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. So we've got that part of it. Now we just take the short leg times root 3 to get the intermediate leg or the long leg, and that is what h is equal to. H is 2 root 3. Okay, so here we're going to do some more solving. Problem 3 says that we have a 90 and a 45-degree angle. We should be able to use the property of triangles to say the other angle must be 45 degrees. And that means we would use the 45, 45, 90 rule. So for problem number 3, x is 7 root 2. For problem number 4, we see it's isosceles. That means it's 45, 45, 90. So problem number 4, x is equal to 5 root 2 times root 2. So x is equal to 5 times root 4, which means that x is equal to 10. When we look at number 5, we see that we can divide um, by root 2 to get the leg. So for number 5, x is 3. And for number 6, again, we see it's 45, 45, 90. So we would divide the hypotenuse by root 2 to get the leg. So we would say x is equal to 9 divided by root 2. We don't like radicals in the denominator, so we rationalize. We say root 2 over root 2. This gives us 9 root 2 over the square root of 4. For number 6, x is equal to 9 root 2 over 2, because the square root of 4 is 2. 2 does not simplify into 9 evenly, so we just leave the answer in that way. In this next set, we focus again on 30, 60, 90 triangles. So 30 is opposite the short side. The short side is half the hypotenuse. So we can say for number 7, y is 18. And the long side, x, is root 3 times the short side. So x is 9 root 3. You see that what we're trying to do here is the rapid math from using the rules. Number 8, again, we see it's 30, 60, 90. X is the short side. 3 root 3 is the long side. So since the long side is root 3 times the short side, that means x must be 3, because 3 times root 3 would give us the long side. And once we have that x is 3, we know the hypotenuse is 6, because it's twice the length of the short side. Again, if we fill in the angles, the short side is always opposite the 30-degree angle. Number 9, we can put in our angle. We see this time y is the short side, x is the long side, 24 is the hypotenuse. So the hypotenuse is 2 times the short side, so y is equal to 12. And x is the long side, that is root 3 times the short side, so x is 12 root 3. Number 10, 30 degrees is opposite the short side, 90 degrees is opposite the hypotenuse. We would divide 12 root 3 by 2 to get the short side. That means that y is equal to 6 root 3. And then x is the long side. It's going to be opposite the 60-degree angle. And we would take the short side, which is 6 root 3, and we would multiply it by root 3 to get the long side. So x would equal 6 times the square root of 9. Square root of 9 is 3, so x would be 3 times 6, which is 18. So that's our section on special right triangles and using the 30, 60, 90 rule and the 45, 45, 90 rule. Okay, watch the video, pause it, take notes, and do the practice work.